In this video, we're going to figure out what the derivative of arcsine is. Now, if we do it the formal way, we end up with something that looks like this. And that is not a happy thing for us. We don't know how to play with inverse sines in this fashion. So let's see if we can do something different. Normally, whenever I'm unhappy about something like this looks ugly, I try and think of a different way I can write it so I'm not as nervous about it. So this is what we have. We have inverse sine, and I'm going to go ahead and rewrite this as a plain old sine function because I'm so much more comfortable with sine than I am with inverse sine. I know how to play with sine quite well, relatively at least. And what we're going to be looking for is the derivative of y with respect to x. So this is what our goal is, dy dx. We want to know what that is. And notice over here, we're treating y as an angle. So let's make a right triangle to help us visualize this. Here's the right triangle, my angle y, and I know that sine is x, which is, if I write as a fraction, is x over 1. And if I put those into the right triangle as lengths of sides, I end up with something that looks like this. And then by Pythagorean theorem, I can figure out that the adjacent side is the square root of 1 minus x squared. Okay, so let's do implicit differentiation on this guy right here. We want to go ahead and take the derivative with respect to x of both sides. Don't forget the chain rule. And the chain rule, by the way, is the fact that we have this dy dx involved. And when we solve for dy dx, it's 1 over cosine. But remember, over in this triangle over here, we know that cosine is just adjacent over hypotenuse. So the cosine is really just this guy. And if we plug it in, we know that dy dx is just 1 over the square root of 1 minus x squared. And we did it. This is the derivative of arcsine. So just to review, we don't want to look at something that's ugly like this guy. So we did all our work, and implicit differentiation allowed us to do this. And if you do the same thing, you can figure out the derivative of arctangent. I would suggest trying to figure out why it's 1 over 1 plus x squared. Just go through the same process and you've got it.